Picture this. You're sitting in the exam hall. The invigilator says, "You may begin," and you flip open that Cambridge Mathematics past paper. Maybe you're tackling the foundational 0580 paper, pushing through the 0606 or 437 additional maths, grinding out the 4024 or 4040, or maybe you're staring down the beast itself, the ASNA level 9709. The timer starts ticking. Now, if you approach these papers simply hoping to react to the questions as they appear, if you're just waiting to see a trigonometry question and then blindly throwing equations at it, you are already on the back foot. You've lost before you've even picked up your pen. Welcome, everyone, to today's Explainer. Today, we are going to completely reconstruct how you view solving trigonometric equations. This isn't just a math test, it's a strategic chess match. It's not just about knowing your sine from your cosine or reciting the unit circle, it is entirely about anticipating the examiner's next mental move. You need to think 5 moves ahead. We are going to decode the exact highly guarded strategy you need to dominate these syllabus codes. So grab your notebook, clear your distractions, and get ready because we are mapping out the Grandmaster playbook.
Look at this quote from a recent principal examiner report. I want you to read it really carefully. The difference between a B and an A-star in mathematics often comes down to how well you understand trigonometry. Notice how this senior examiner explicitly states that top marks require a deeply conceptual, connected understanding. It is not about rote memorization. The difference between a good grade and a perfect grade isn't necessarily about working harder, it is about working with absolute clarity. When an examiner looks at your paper, they aren't just checking to see if you memorize the double angle formulas. They want to see the theoretical architecture behind those formulas. Can you define the precise relationships? Can you integrate trigonometry with calculus or coordinate geometry? Time and time again, the examiner reports highlight that candidates who reference cross-topic connections achieve significantly higher marks. It's all about logical, structured reasoning. And that's exactly what we're going to build today.
Let's look at a dynamic split screen of 2 typical candidates we see year after year. On the left, we have Alex. Alex is our overthinker. Alex sees a 6-mark trigonometry question and panics. What happens? They overload the page with raw math facts. They immediately write down Pythagoras, the sine rule, the cosine rule, every identity they can recall, hoping the examiner will just give them marks for effort. It's an absolute data dump, but there is zero structural analysis linking those facts to the specific question. It's a mess of red pen. Now on the right, we have Sam. Sam is our speed racer. Sam rushes the problem, eyes constantly darting to the clock. Sam jumps straight to crunching numbers and entirely ignores the command words. The question explicitly says, hence, solve, which means use your previous answer. But Sam completely misses that requirement, starts from scratch, wastes 5 minutes, and gets it wrong anyway. Neither of these approaches works. Why? Because Alex and Sam are playing checkers, while the Cambridge examiner is playing chess.
To ensure you don't end up like Alex or Sam, here is our Grandmaster playbook for today's session. First, we'll establish the core principles, the opening moves. Second, we'll reveal the procedural framework to dominate the mid-game. Third, we are going to run a high-intensity interactive workshop to test your skills live. Fourth, we'll map out how to dodge the fatal examiner traps. And finally, we will lock in the checkmate system. Let's set up the board.
Moving into Section 1, Core Principles. Let's talk about your opening moves.
The crucial point in your opening moves is understanding what Cambridge actually wants from you. The syllabus aggressively prioritizes analytical depth over superficial breadth. An examiner would much rather see a beautifully structured deconstruction of a single equation than a frantic, messy attempt to mash 5 formulas together. Cambridge assessment objectives target the 3 distinct cognitive domains you see mapped out here. First, knowledge and understanding. Obviously, you need your identities locked down. But look at the second bullet, application to unfamiliar contexts. This is where most students freeze. The exam will purposely present a trigonometric equation in a weird, novel format. And finally, deep analytical evaluation. To conquer all 3 of these, top students use the Peel framework. Point, evidence, explanation, link. Make your mathematical point by stating the identity. Provide evidence by substituting the exact values from the question. Write out your explanation through clear step-by-step algebraic manipulation. And finally, link your final numerical answer back to the specific command word in the prompt. That is how you prove deep analytical evaluation.
We hear this question from frustrated students constantly. Why is it so incredibly difficult to secure those multi-stage method marks when I know I have the right mathematical tools in my head? Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
So, let's decode that mystery. The answer lies entirely in the method mark strategy. This is the ultimate secret weapon of the A student. You have to realize that Cambridge mathematics papers are specifically designed to reward the process, not just the destination. Imagine you're solving a massive trigonometric proof. You write line 1 perfectly, but on line 2 you accidentally drop a negative sign. A tiny, silly arithmetic error. But, and this is a massive but, if your analytical framework and your logical sequence remain flawless for the next 6 lines, applying the Peel framework perfectly despite that early error, the examiner actually wants to give you marks. They will award you method marks for a correct methodology applied to an incorrect prior value. But they can only, legally, award those marks if your working is visible, highly structured, and clearly communicative. You are literally guiding the examiner through your brain. If you hide your steps, you hide your marks.
That brings us to Section 2, the procedural framework. This is where we execute the mid-game and start racking up those guaranteed points.
By religiously following this strict 4-step sequence, you are practically forcing the examiner to award you points. Let's look at the mathematics success blueprint. Step 1. Deconstruct the question and extract the relevant data. Don't just read it, scan it. What is the domain? Is it 0 to 360 degrees or 0 to 2 pi radians? What are the boundaries? Step 2. Select your analytical framework. This is where PEL comes in. You decide exactly how you're going to attack it before you write a single number. Step 3. Execute the analysis with absolutely crystal clear working and appropriate notation. Step 4. Verify the results and present them in the required format. Did the question ask for 3 significant figures? Exact values? Let's mentally rewrite Alex and Sam's disastrous answers from earlier using this blueprint. Imagine the red pen marks transforming into green check marks on the screen right now. We take Alex's messy data dump, extract only the relevant sign identity, apply step 3 to execute it cleanly, and suddenly a 0-mark answer becomes a perfect 6. We take Sam's rushed mess, pause at step 1 to read the command word hence, use the previous answer, and boom, full marks. It really is that systematic.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's get hands-on with Section 3, the interactive workshop. It's time to test if you can actually dodge the examiner's traps under pressure.
We're going to put a 60-second timer on the clock for Challenge 1, the data scan. Imagine scanning a dense, complex trigonometric word problem. Maybe a graph showing tidal patterns over 24 hours. What are you looking for? You are hunting for the specific details that trip up 80% of candidates. The top 3 mistakes are right here. First, answers are too vague. If the trend shows a cosine wave, just writing "it goes up and down" gets you 0 marks. You need specific mathematical detail like amplitude and period. Second, forgetting format. Are your axes labeled in radians or hours? Third, lack of context. If the trigonometry models a real-world tide and you calculate a water depth of -5 meters, you've made a mistake. Your final evaluated answer must make physical sense within the context. 30 seconds left on the clock. Train your brain to spot these instantly.
Time's up. Moving to Challenge 2, find the flaw. Look at this explicit examiner warning we've pulled for you. Terminology confusion. The consistent failure by candidates to clearly define key trigonometric terms before executing extended responses. This is a massive red flag. Let me give you a flawed sample paragraph. Imagine a student writes, "I use the angle formula to change the shape, then solve for x." Can you spot the flaw? Take a few seconds. The flaw is terminology confusion. Which angle formula? Double angle? Compound angle? What do you mean by change the shape? If you don't define your terms with precise mathematical language, your entire logical argument collapses. The examiner cannot confidently follow your logic, and those precious method marks evaporate instantly. You have to communicate like a highly trained mathematician, not a casual observer.
Now for Challenge 3, speed writing. I am giving you 30 seconds on the mental clock to completely reframe how you write your answers. Notice the transformation here, from a vague, weak response to a specific, mathematically contextualized masterpiece. The top answer, solve the sine equation, is our classic, vague, no-mark trap. It shows intent, but it completely lacks analytical depth. Now look at the contextual answer below it. Apply sine rule, define boundaries, evaluate limits. That is a perfect Peel paragraph distilled into its purest form. It tells the examiner exactly what procedural framework you are applying. It explicitly hits the cognitive domains of application and analysis. If you can train yourself to write with this level of precision, you become virtually bulletproof in the exam hall.
We are now entering the end game. Section 4, the checkmate system. Deconstruct, solve, evaluate.
To truly achieve checkmate and secure that A-star, you absolutely cannot just stop the moment you hit a numerical answer. You must critically analyze your own evidence quality. Step 1. Identify limitations and assumptions. If your trigonometric model assumes a frictionless pendulum or ignores air resistance, you need to state that assumption clearly if the question implies a real-world model. Step 2. Evaluate alternative interpretations. Ask yourself, could this exact equation be solved more efficiently? Did I take the long route by expanding everything? Would a simple double angle formula would have saved me 4 minutes? Step 3. Check reasonableness. I mentioned this earlier because it's vital. If you crunch the numbers and calculate an angle of 400 degrees, but the bold text at the top of the page stated the domain is specifically between 0 and 180 degrees, stop. Your answer is not reasonable. You must evaluate your limits, reject the invalid solutions, and justify the ones you keep. This descriptive analytical framework is exactly what separates the top 1% of students from the rest.
Let's pull everything together into our ultimate cheat sheet recap. This right here perfectly summarizes the complete mathematics answering system. There are 3 rules that guarantee top marks, and they form our time management matrix. Look at the first row. Grandmaster move, decode the command word. The action required, extract data. The result, you secure your method marks. Second row. Grandmaster move, framework application. That's your PL structure. The action, clear notation. The result, you lock in those presentation marks. Third row. Grandmaster move, trap avoidance. The action, define your terms clearly. The result, you guarantee your accuracy marks. You want to see that progress bar on your mark potential shoot from 0% straight to 100%? This matrix is how you do it. Memorize this table.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Jumping from a C to an A or pushing from a solid B to that elusive A star is not a fantasy. It doesn't require a magical overnight increase in your raw intelligence. What it requires is a radical, disciplined upgrade in your strategic execution.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Take these grandmaster strategies, apply that Peel framework, and go dominate your next paper. Until next time, keep analyzing, keep thinking 5 moves ahead, and keep solving.